So what we are going to do now is this. I'm going to show you a problem, a situation, and I'll tell you what are the decision factors that our decision makers ended up wanting to evaluate and how these decision factors are expected to affect the final outcome. Then we are going to go to breakout rooms, each team in a separate breakout room, and I will ask you to use the tools per decision to set up an AHP, ANP, and ratings model, all for the same situation, so we can practice, and me and Liron can help you along the way with your practice models. After a little while, we are going to reconvene and we will discuss together about the results that we got and how and why they came out like that. So let's start by looking at the model that we want to solve. In the link that Liron gave you, you can already find it under intro production example. So you can have your own copy of it while you solve the problem. We have a small manufacturing company that uses flexible manufacturing cells to produce 3 different products. You see over here a small simulation that was used in order to identify and evaluate different products that are being produced in this company. We have the simulation of the process for all the incoming parts over 1 work month. We have seen that the competition has started producing a new product, and the demand for this product is expected to be very high the next 3 years. Our production manager is concerned because product's B demand has been unusually low the last quarter. We are already producing A, B, and C, and we are evaluating whether we should change the product mix and or add product D to the production mix. What do we know about this product? Well, from the quantitative side, we know the processing time as a minimum and maximum, the per unit profit, and the time in system required for each of the products. And you see over here the first table that you can use for your decision. The first decision that we want to go through is which 3 products should we produce? We had a meeting with all concerned partners, and they are trying to define what are the decision factors that we should consider in this decision. After some brainstorming, we ended up with the following decision factors: profitability, processing time, demand, fit with the other products, alignment to the company's goals, and expected time in system. Now, how are we going to combine the tangible and intangible factors to make a rational decision? Well, as you can guess, we are going to use AHP. What we want to do is set up, first of all, an AHP model following this setup. Then we want to go and set up also an ANP model and compare the results between the HP, the ANP, and even the ratings model. So our end result should be the comparison of AHP versus ANP and ratings. Going back one step, what are we going to do now? First, you're going to take the description of your model and set up your HP model. The HP model will be composed from these 6 factors. How are we going to evaluate the factors? You have already information for each of these factors. You do not need to use the judgments that you see in the following pages. as long as you follow the general idea that our decision makers actually had. After you set up the AHP model and enter the judgments, you would like to collect the results in an Excel spreadsheet and also do the AHP sensitivity analysis. Now, let's go to our breakout rooms. I'm going to stop the recording. And we are going to meet you inside the breakout rooms and help you. Don't forget, you can call or message from within the breakout rooms to ask for help. This is the model that you were also setting up. I have obviously entered also the judgments exactly like you did. And let's see. Did you see that message that I made pop up? It's because I forgot to hide my left-hand side panel. That's a warning for you. Always remember to hide the left-hand side panel before you start working on your judgments. There are some things that probably you noticed today while you were entering your values. For example, it's not allowed to put anything that is not a number over here. However, you can put decimals. In case that you put a decimal value, like I'm doing right now, it will change from red to blue and give the dominance to the row instead of the column, and the opposite. So if I put here 0.333, it will go back to 3. I think that you did extremely well with the setup of your model. That's why I want to take you and see the sensitivity analysis. First of all, why do we do sensitivity analysis? We do sensitivity analysis for 3 reasons. Reason number 1, so we can find out if small changes in the judgments under the matrices are going to affect the final results. We don't want that. The second thing that we want to do is whether the changes will cause a big difference in my results, if they will really affect what I'm trying to do. And the third thing is that we are trying to find out how to influence the decision. There are a lot of times that we really want to know how to make a decision go our way. In that case, by know which entities are sensitive to the change, we know also how to affect the final result. For example, if I know that fit with the company values is what a product lacks, and that's why we are not producing it, then I know how to work towards making it one of the products that the company will choose. When we do sensitivity analysis for an AHP model, edit independent variable, edit super matrix, and then we will do a sensitivity analysis for each of the nodes that we get. So for each of the important criteria. Sometimes when we know that the priorities of the criterion are very low, we might omit that specific criterion. Done, update, and we see the values here. It's a nice graph, but it doesn't make much sense unless you know how to use it, right? First thing that you need to do. You need to open up your computation priorities. I'm actually going to copy the values and use my Excel spreadsheet to save them so I can have a visual of my priorities. I specifically care right now about the priorities that relate to the criteria. So I'm going to focus on those values only. Here we are. And I'll take the first graph that it came from my system. which is over here. Next to it, so we can read it. Graph. What does it say? This is the sensitivity analysis for demand. I'm focusing first of all to the red and green line, and I go to the cross point immediately. The cross point tells me that at 26%, when the priority of demand is 26%, there is a change in ranking, a rank reversal. Instead of having the red product A to be the best one, product D, the green one, becomes the best one. In other words, as the priority that I pose to demand increases, the how good fit is D increases as well. So the more we care about the demand, the more we would like to produce product D. The less we care about demand, the more we would like to produce product A. And that's one part of the sensitivity analysis. At the same time, I want to evaluate whether this number, the 26% that I have here for the cross point, is close or far away from the actual priority. The closer it is to the priority, the easier we'll get a different result when somebody enters different, with small differences, values in the model, which we don't like. That's what we call sensitive to changes. So 0.26 versus 0.231, it's not a huge difference, but it's really well within what we would say that is pretty good. It's a robust model. It needs more than 5% of change to happen in order to change the result. Let's see what happened with the other models that we have. I'm going to do the sensitivity analysis for my second factor. Edit, independent variable, edit again, super matrix. With respect to goal, let's see how profit affects our result. That's the opposite situation. No matter what's your preference on profit, product D will be always better. Product A will be always slightly less good than product D. However, the priorities of your products B and C will change. The more you care about profit, the more product B becomes a better solution with respect to product C. Is that something that will easily change? Normally, we focus to the top two choices, but right now, since we have the chance, we can evaluate also this one, the second pair. Well, here I see that profit is at 33%. The cross point is at 49%. I would say that it's really difficult to see a change even in the ranking of the third and fourth option. And let's see the next one. Fit. Different situation here. We have a cross point at 17%. The actual priority is 13%. Not very close, but close enough to make me think about it and consider the situation. Same case. The more you care about the fit, the better A becomes. The less you care about fit, the better product D becomes, which makes sense. product A is the new product, is the old product, everything complies with that. The mission, the goal of the company, everything was made with respect to that product. That's the initial breakthrough that they had. While product D is the newcomer, it's a completely different product. That makes sense. The fit of product D is not really good at this point of time. It's the newcomer. And also, as the fit becomes more important for you, you will stick to the previous product. As fit becomes less important to you, you will go to the old product. Let's see what happens with the other factors that we have. Super matrix, following the same. Processing time. Not too much, but here. I have a turning point at 27% with actual priority 0.06. I don't care. I will not even discuss about something that happens so far away from my actual priority. Alignment. Okay. Rank reversal at 15%. Actual priority 11. This is a pattern now. Demand, fit, and alignment. The more you care about fit and alignment, the better product A is. The more you care about the demand, the better product D is. And the last one, timing system. We don't have a rank reversal between the first two. However, if the timing system starts becoming a problem, then the best solution will become product C, which is really fast to produce. Are we good so far? Excellent. That's how we use and evaluate the sensitivity analysis. Now I'm going to open our other model that was the ratings model. See that I don't have any more alternatives in my ratings model. That doesn't mean that I don't really have alternatives in the decision-making process. It just means that they are not on the front view. If you go to the rating side, you will see that I have selected all the bottom level criteria. I added the alternatives that I had before because we want to compare the methods. Otherwise, I would have more. That's why you use a ratings model. And for each of them, I created my own scales. Okay, the truth is that I started from the high, medium, low, and I developed it every time that I needed more items. And I went to compare in order to set up the priorities. So I set up what's, for example, how much better is when you have processing time more than 150 or less. And based on this information, I set up my priorities. The moment that I saw what I liked, I stopped setting it up. Now, this is one of the sets of priorities that you would like to see inverted. See? Because the more time you are in the model, in the processing state, the worse it is for the factory. Alignment with the goals of the company and timing system. And then I went and I entered my evaluations for each of them without pairwise comparing this time. So it was faster. I think that you noticed when you were doing this exercise, but at the same time, it was a little bit scary because you need to really know what's happening for each of the perspectives in order to be able to evaluate them. Now, the third model, we are going to compare the results in a second. I want to see also my AHP version of this model, which at first it might look simpler than the previous two, but it's not really. I have on my criteria connected to the alternatives and the alternatives back to the criteria. And that means that if you go to the judgments, now you will be able to see demand, for example, with respect to products A, B, and C, but also product A with respect to all the criteria that we had. Demand, profit, fit. How do we read this one? What does it say? It says that product A has a really good fit and alignment with the goals of the company. The demand is not very good. Profit, also not very good. Processing time and timing system are not exactly the best characteristics of product A. And if we compare it with product C, then we will see that product Product D has much higher demand, but not a very good alignment and even worse fit. However, the profit is good, the processing time is acceptable, and the timing system is acceptable. And that's why, if we go now, to our PowerPoint, we will be able to compare the results and get a little bit more insight about the situation. Here we are. This is the result that we got from the AHP method. Product D is the best one, product A, the second best, followed by C and D. So if we wanted to produce two products, then we would produce A and D in the given ratio from the numbers. And if we are going to go for three products, then we are talking about A, D, and C. When we go to the A&P result, you will see that product A makes a much larger percentage of the results. So product A is the best one, followed by C, and then B and D. While ratings are similar to what we were saying in AHP, with the difference that now the product D comes up even higher in our pairwise, in our synthesized result. Why is happening that? Does it make sense? Is it that the methods are not working well? Well, actually, they are working more than well. They are doing exactly what they are supposed to do, which is help you decide different things in different situations. A&P will show you how things really are, the current situation at your company. And the current situation at your company is that product A is the best fit from those that you have because it fits well, it has a good alignment. While AHP allows you to tell the system, hey, I would like these priorities. If these are my priorities, what should be my decision? So we're talking about two completely different perspectives in this case. Now, ratings. Why did ratings came up with different results? That is a little bit more complex, really. The reason that ratings come with a different result is that in ratings, it's a little bit easier to let your bias come through. And that's because you're directly entering values and you are in control. So since I, as a decision maker, thought that the best option was to go for product D, you see that reflected in the results. And you will say, how are we going to trust a method that allows you to be subjective? Well, actually, that's why we choose this method, in order to allow the people that should decide to show their perspective. And the way that we balance out the situation is by having group decision models. So allowing different people entering values from different perspectives in such a way that the decision makers are involved and show their personal opinion, while the final decision finds the proper trade-offs among those decisions and gives you a result that will be easily followed by the full team. Now let's see one more step. It won't take us more than a minute. Have you all done linear programming? Let's see about it. What do we have here? We were informed that one of the factories providing us with a specific material has been destroyed by a major fire, and we are expecting to have shortage of materials for the next 4 months. We are wondering, how should we adapt our production schedule? Now, from the ratings model, I took the value. How much should I produce for each of them? Look, these are the values that I found out during my production setup. Then, for each of my products, I identified what are the needs in materials, in material X to be more precise, because that's the one missing. I defined that effectiveness is the idealized value of the priority. And I had also that for each unit that I'm producing, I'm going to bring in that corresponding amount of material. What I'm trying to do is to optimize my performance score, which is units that I'm producing times the effectiveness for each of the products. And my major and primary constraint is that the total units of material X that are used needs to be less or equal than the total units of material that I'm expecting to have available. Now we have also some balance constraints, because as you realize, everybody likes product D that brings more profit, and product A, we made sure that not everything will be product D and product A, by setting up two constraints that say you cannot produce more than 40% of your total production products D, and you cannot go above 40% also for products A. Similarly, we wanted to make sure that we will have some units of products B and C. So we said you cannot go less than 5% for products B and C. And setting up this as an optimization, you end up finding out how many units from each product you should use in order to optimize the situation at the production level. Summarizing, with HP and P family of methods, you saw that we can combine tangibles and intangibles. We can have mathematically sound solutions to problems that involve data from a system, but also personal perspective and experience, because we don't want to take out one or the other from our decisions. And sometimes, if we need to, we can also combine our results with optimization methods to solve even more complicated methods. And we choose the method based on what we have available about time, needs, level of confidence to our decision. And I think that we have shared more than enough for our first day.